One of the ways to understand convolutional neural networks is to compare them with densely connected neural networks, or also called feed-forward neural networks, and look at the difference. In a feed-forward neural network, what happens is if you have, say, for example, a tabular data, then entire set of row with all the values need to be fed into the neural network for it to make predictions, right? In other words, if I have to, say, for example, take a look at a picture and decide whether that picture contains a face or not, then I have to somehow encode this image into a long vector of information, which could be really long, and then feed this to a feed forward neural network model for it to make predictions. So you can imagine that this neural network that accepts this entire image must have at least a lot of neurons or a lot of connections to accept every pixel from this image into the neurons that you have. So this becomes a lot of weights or a lot of connections between your input image pixels and the neuron or the neurons that you have to make a decision. Now, convolutional neural networks operate in a very different way. In a way, convolutional neuron, what it does is what a lifeguard does at a pool. Maybe some of you already actually served as a lifeguard and you know exactly what a lifeguard does. A lifeguard scans the pool surface, creating an output map. So, say for example, you have a pool like this, and then here's the lifeguard looking at the pool, watching the pool. The way lifeguards are trained to look at the pool is they will start from maybe one corner and continue to look in this direction, creating a grid of regions that they have to watch out for, and then they go back up to the other corner, and then they come back again, and then finally they reach this point to say, okay, one scan complete. Maybe they do this in 20 seconds, and then they are back up again to the beginning and they keep scanning. So particularly in large swimming pools, it's very important, because if you look at the whole swimming pool at once, it's very difficult to catch if somebody is drowning or not. But if you instead take this approach of breaking the entire pool area into smaller pieces and then watch them this way, you're guaranteed not to miss anything in the pool. Now, convolutional neural networks, or one convolutional neuron, is exactly similar to that. Unlike regular feed-forward neural networks that look at the whole thing at once, so look at the whole thing, the whole image at once. Here, in case of a convolutional neuron, what happens is you have maybe one tiny neuron, a very tiny neuron, that looks at one place at a time and then keeps moving, looks at another piece, looks at another place, and keeps moving until it finds what it's looking for. So this is more like a tiny neuron with very few parameters that can do a really big thing of scanning an entire image. And this is what makes convolutional neural network very different from regular feed-forward neural network. Now you can imagine a convolutional neuron, one convolutional neuron, as something like an eye with a memory attached to it. So just like a lifeguard trained, so your training sits in this memory right here. So here's your training, right? So the knowledge that you have to know what to look for. And then this is attached to an eye that can start looking from one corner and keep sliding all the way down, and then all the way to the end, finding what you are looking for based on what you have in your memory. Now, many times, instead of having one convolutional neuron that scans the entire swimming pool, or one lifeguard, if you have multiple convolutional neurons, or say, for example, here multiple lifeguards, one lifeguard could focus on a particular aspect of the swimming pool. Say, for example, one lifeguard may know the relationship between light reflection and drowning. So maybe this lifeguard is very expert in identifying drowning cases of drowning based on light reflections. Another lifeguard may know the relationship between the body size and drowning. So this lifeguard can very quickly catch if somebody is drowning based on body size. Another may know the relationship between the water splashing and drowning. So this way we have one neuron, two neuron, three neuron, and these three neurons can work independently or somehow later together to identify if somebody is drowning or not. So basically, the bottom line is dense neural networks are feed-forward neural networks or dense neural networks are techniques in which you accept the entire image or the entire data at once, whereas in the case of convolutional neural networks, you have one tiny neuron, usually of only maybe 3 by 3 or maybe 5 by 5 size, which is just maybe 9 parameters or 25 parameters, sufficient to catch what the pattern that we are looking for in the data. The difference between convolutional neural networks and densely connected neural networks can be very, in a way, summarized using this in this YouTube ad of Coca-Cola. Here, the Ant-Man can be compared to CNN, and the Hulk can be compared to a neural network. So many times, to do something big or to do something that you're interested in, the Ant-Man may be sufficient and you may not need a Hulk. So Hulk is more like neural networks. The size represents the number of parameters. So neural networks, feed-forward neural networks have a lot of parameters and they are like the Hulk. Whereas convolutional neural networks have a very few parameters, and in terms of number of parameters, they are like the Ant-Man.